Hey everybody, what's up? So I'm going to be doing a CTFChallenge.com video today. I did a video on the site before where I just did kind of a small review and a walkthrough of one of the other challenges. And I'm doing it here again because, I mean, everyone does try Acme and Hack the Box videos, so I just thought I'd do something a little different. And the challenges on this site are just like super good. So I just wanted to go ahead and make another one. So I'm going to be doing the VulnRecruitment challenge. It's the medium challenge. And so I've actually already done it before, but I'm going to go through and basically pretend I have amnesia, because I figure if anyone's watching this video, they're doing it so they can try and learn. So I'm going to kind of use it with that as like the focus. Also, so for each like exploit or path or whatever to get to the different flags, I'm going to try and use a different technique or script or whatever, just to try and like kind of expose some more things, or I don't know, maybe it'll make it more entertaining, fingers crossed. So anyway, let's go ahead and jump into that. So if you're not familiar with the site, they do give you a challenge cookie, or a cookie, and that's kind of how they keep track of you. The site actually does have a rate limiter, so we're going to be using that a lot, so I'm just going to copy that. I'm also going to set up a variable for it so we can use it in our command lines, because every request you send to the server has to have that cookie. And then I'm also going to set it in tmux, in my tmux session, so that it's also available in all the other tmux panes I open up. So like, that should be here now. Okay. Let's turn on burp and go after it. So the first thing I'm always going to do is just do a DNS on the domain. See what kind of information we get. We see it looks like it's probably running on a DigitalOcean instance. And here's the A record with the IP address. And I'm actually going to go ahead and copy that and put that into the scope for Burp Suite, so that I don't get any other stuff cluttering up the history. And then I'm also going to go ahead and when I do challenges, I like to go ahead and turn on everything. Usually it's not loading so many resources and stuff that it just becomes overwhelming, and you actually can, this way you're sure to not miss anything, which actually kind of comes in handy on this challenge. And then I'll go ahead and start just firing up some enumeration scripts. So we'll use fuff, and I'll do a subdomain scan first. So on this site, they do give you a word list, which is nice, because, like I said, it's rate limited, so you don't have to use any of this super big sec lists or anything like that. If there is something you need to find, it'll be in one of their word lists. And so here I am setting 2 threads for a 1/10 of a second pause between each request, just to keep it under the 10 requests per second. So I know math-wise that should work out to like 20 a second, but I don't know, maybe it's just the way my VM's set up or whatever. It ends up being about 7 when I do it like this. And then, like I said, we have to send the cookie on every request, so we're going to create a header, a cookie header, and then we'll give it that variable. And then, since we're going to subdomain, we'll use the host header. Oops. And this is what we'll be fuzzing for, and then just give it the URL. I don't know if you need HTTP or not, but we'll throw it in anyway. And that should work. And then I would go ahead and also start to do like a subdomain enumeration on the main one, or not subdomain, just like the directory brute force. So like I said, they do give you a word list, but even then, since I don't want to have to like figure out how to edit videos and try and like speed that up while you're just watching lists go, or enumeration go, I actually just went ahead and created a custom list. So normally you'd use content, but I just made a temp one that's smaller. And then we got to give it a cookie again. And this time we are fuzzing the actual directory structure. Like I said, you only get 10 requests per second, so I can't run both of these at once. So spoiler alert, the only subdomain we're actually going to find from this scan is the admin one. So I'm just going to go ahead and stop that one so I can start this one. And then the other thing I like to always do is keep just a little note file where I store a bunch of information, so that like when I come up to a dead end or get stuck, I don't like forget like, oh, there's stuff I should do. There's actually like a lot of people have like some really nice templates and stuff, especially for like cherry tree nodes, where you really can increase your efficiency and do some nice things with, but I just haven't messed around with that yet. So anyway, let's go back to the site, just check out the main page real quick. First thing I always end up doing is just checking the source of the main page, seeing if there's any kind of a lot of times, especially on easier challenges, you'll get comments that'll give you something. Basically, just looks like there's just the one link on the main page. Let's go ahead and actually check out this admin one, because since it's admin, it sounds exciting. So we'll go ahead and look at that first. And we see we're not allowed access from this IP address. So right away, that's got me thinking this is going to play a point. At some point, we're going to need to probably be able to view this page. So we're probably going to need to find some kind of like server-side request forgery or something, so that we can get, I'm assuming it's probably like a local host address, or some whitelisted thing that we're going to have to find a way to like get into that maybe. So then let's go ahead and check out the only other link we know about currently. And we see it's just some staff members. So we get some names. Let's go ahead and look at their profiles. So we get some email address. So let's go ahead and just copy this stuff, because that seems like it might come in handy. And we see it's going to just a numbered subdirectory. And here we see we jumped from 2 to 4. So obviously the first thing we're going to want to do here is let's see what's up with 3. And we see staff member no longer works for VulnRecruitment. So that definitely probably seems like some important information. So we'll just make a note about that. Number 3, where'd they go? And let's see if there's a 5. Invalid ID. Let's go ahead and, is there a 0? No. So let's go ahead and see how that scan is coming along. And so it looks like all we did was just find the staff that we already know about, and then the CSS and JS, which were 301. So I'm assuming they just redirect to like the end thing, and then we get a forbidden. So let's go ahead and bring our enumeration one step down, so we know there's a staff. Let's go ahead and look at that, and then let's just take a scan at like Burp Suite and see. I wanted to see what the admin. Oops. So we see when we went to the admin subdomain, we did get 401 unauthorized. Let's see what would happen. I'm send it to repeater, and let's see what happens if we just go to some page we know is like doesn't exist. Like what will it? So it just gives a 404 not found. So maybe we could, try and brute force directory search these subdomains. Maybe it only is, if you know the resource, maybe it's only giving you that we're not allowed to see it. Something to keep in mind. Also, if we saw when we were looking at that, we see here we have, it looks like the images that are loading for the employees is coming from a get query parameter. Let's go ahead and just send that to repeater on whatever this image domain page is. So that's something to keep in mind too. Like, let's see what the actual request looks like. I should just looked at it in the window, but so yeah, also all this gobbledygook is a picture. So it looks like it's getting the picture from this somehow. Let's see what happens if we give it something that doesn't exist. And here we get a 200 response, but then the data we get back is 404 resource, this domain not found. So what this makes me think is whatever is in place on this, also let's just go ahead and look at that too. Whatever is in place on this image, oops. Let's see what that is real quick. Missing image ID. So whatever's in place here, it looks like what it's doing is just taking we have control over this input, right? Like we can change it, and then it looks like it's just taking that and sticking it directly into the file name for like this URL it's going to. So, because it looks like we're actually getting some kind of, like it's sending off to get that, and the response it gets is then what it gives us back. So like if we went back to the original one, so what I'm thinking here is this URL, if we go to it, but instead of that gobbledygook, we give it the actual image name, this should actually be a file. This is where the image file actually is. It's being stored on this path here. Yeah. So that is something to make a note of, because let's just say staff 1 image ID. We'll just keep that parameter to remind us, like, maybe there's something we can do since it's taking user controlled input and then sending off a request. Maybe we can do some kind of like request splitting, HTTP request splitting. Maybe, we could figure out command injection or who knows. We don't actually know how it's handling this, but something to definitely keep in mind. And then since we did get this new subdomain, let's actually just go ahead and see what's going on with it. And we're going to see file storage engine, and here this is going to be our first flag. And then we're going to get a message letting us know that there are many ways we can put our files here, and then why not have a search. If we hover the link, it looks like it's just going to a redirect page, and then it's taking another parameter that I'm guessing we can control the supply of. So let's just go ahead and click it and then kind of see that flow, how it goes. So yeah, it's just it sends us a 302 and then redirects us to whatever we put in here. Let's see what just the redirect is. We can just go there, redirect, like without the parameter. Missing URL parameter. So let's go ahead, and we have a couple parameters we want to keep in mind. That we might end up needing to look at. We're trying to figure out if we run into dead ends or next avenues. Let's see what happened so we look that we get a ton of responses, but it looks like anything with a number is a valid response. Kind of like that's their employee ID or whatever. But if you look, they're all just this, like how when we got, what was it, invalid employee ID or whatever it was. What did it say? Staff member ID is invalid. So that's what all these responses are. And we see here with like the 1 and then 2, even 3 and 4. All the rest are just invalid IDs. But we also see there is a portal, 302 redirect. So let's go ahead and portal. Let's go there, and then we might as well just go ahead. Should always try and do always try and have some kind of scan running in the background if there's still anything you could possibly still be scanning for, just for efficiency. I mean, enumeration is the most important thing in any of this stuff. So you just always want to, the more information you can get, the better. So always, no sense in wasting time by not running a scan if there's a scan you could run. So it looks like here we have an email and a password, and it's a login. And conveniently enough for us, we have some emails. So let's see if we can, what happens if we try and log in with these names. So user does not have online access. All right, so let's try Archie now. And invalid email password combination. So that makes me think that Archie actually has a login. Has login pass. And then let's go ahead and check out Abby as well. So she does not have online access. So this is actually pretty good for us, right? So we had 3 possible IDs. We know one of them, and we can go ahead and let's just go ahead and try and brute force our way in. One of the nice things, like I said, with this site is they give you the word list, so you don't have to worry about running some giant like RockU or whatever to try and see if the password is brute forceable. So let's just go ahead and we'll try the brute force with this. I'm just trying to think of what I should do. Let's go ahead and, oh, so here are their scan finished, right? We just see there's a login, log out, and uploads. So let's see what uploads is. And it just redirects us back to the page. So I'm assuming what that means is we need to be logged in, that they'll set some kind of cookie in our login, like a token or something, and then we'll be able to see that page if we're logged in. Oh yeah, so what I was going to say is let's go ahead and use Hydra, which if you're not familiar with is just like a kind of a brute forcing tool to use on, it works on a ton of different like protocols, but we're going to use it to try and brute force into this page here. So what we want is, let's go ahead and we already did that. Here we go. I need one of the responses, right? So because we need to see how it's formatted. So it's a post request. It's form URL encoded, but we're going to need this information here for Hydra. So Hydra, if you're not familiar, it's a tool, comes on Kali Linux, and we can give it capital P for a password list, and this is basically what we're going to use to enumerate all the different passwords we're going to try. And then we give it the website. And then here's where we tell it like what protocol. And we'll be doing a HTTP post form. I think that's the right way. And then here's kind of where post form, all the important stuff happens. In between these quotes, you can separate things by a colon, and the first one you're going to need is we need to tell it the path that we're actually going to. So we're hitting staff portal login. That's the page we'll actually be sending the post request to, and then we're going to give it a colon, and here is where we're going to give it what the body of the request is. in this case. So we're trying to log in like this. And for password, what we're going to do, since we want to be using, each time we send a request, we want a different word from this passwords text word list. The way you put that in is that upper caret symbol and pass. You can also do a username list too as well. Like if you used -L, I think, for login, and then so somewhere in here, say we didn't know, say we had a list of possible emails we wanted to try, we didn't know if any of them were valid, you could replace that with user, and so it would also put that in. And then, so we don't know what a successful request looks like, but we do know that when we try and log in and it doesn't work, I was hoping to fill out the form. Just go to this. It should give us some message. So this one said user doesn't have login access. There was one, I think it said like, oh, here we go. So invalid email password combination. So anytime we log in and it doesn't work, we're probably going to get this message in our response. So we can just tell Hydra to look for, if it sees invalid email, the phrase invalid email in the response, it knows it is a unsuccessful response and that password did not work. And then, like I said, since for this site we have to give it a cookie every time, we actually are going to add a header. So H for header, and then we'll give it the header we want. And Hydra uses these colons to break up the different little segments. So if you have a colon not for that, you need to escape it like that, just backslash, and then we will give it our cookie. Also, since there's a rate limiter, we're going to need to, I don't know how fast this will be, but we're going to tell it to use just 4 threads because we have to make sure and stay under the 10 requests per second. I don't know, maybe I could use 10. I don't really know how fast Hydra is. I don't use it that much. Normally I would always just use, typically I just use Burp Suite for everything that I can. I believe that should be good. Oh, so this is kind of dumb, I think, but it requires a login and password. So like, since we already know who the user is, we can give it anything here, but it needs to have, so say we could replace this, oh, I also want to use, wasn't it Archie that was the login? It was the second user, yeah. We want to, like, I could just replace, or actually let's just go ahead and do that, just so I can demonstrate it. So we could just put, if we wanted to, we could put user here. And then for our login, whatever we put for lowercase l, it will always put that there. If we had an uppercase L and we gave it a word list, then it would change every time. But let's go ahead and I believe this should work. So now it will take this and always stick it, where to go? For user. So I believe that should work. So I should have made verbose so we could see it doing its stuff. But it should be trying them out in the background. So there's only 101 passwords in this word list, so it shouldn't take that long. It's going to try them all and then return the ones to us that successfully, well, that didn't have that phrase in the request, which for our purposes should be a successful login. So hopefully that's what's happening. I guess maybe I could have used more than 4 threads. Or I did it wrong and nothing is happening. Nope. It worked. So we see here request number 80 that we sent. The password Thunder looks like was a successful login. So let's copy that. I also always try and put a little section with credentials. We know that Archie likes to use this password, so maybe that password comes in handy later on. Oh, the other thing I forgot to do was stick in this URL we found, because again, this is another possibility. We could potentially be trying what was the format of that? Uploads. We could try and oops. So like I said, we should always have a scanning going, so I should fire up a scan and try and do that, but I'm just going to be lazy because, spoiler alert, we're not going to find anything. But we are going to now log in as Archie because that is exciting and we don't want to forget to do that. And here we see we don't get to log in yet. We've been sent a 4-digit code to our mobile and we have 3 attempts. So let's go ahead and just try 3 times. We'll go through the process, kind of just see what the web flow is. Too many wrong attempts. Go back to the login page and start again. Can we log in as him again? Why is it not auto-completing for me? So it looks like we don't get locked out after we mess it up, which is nice. So that's something to think about, is that I'm assuming the pin gets reset every time, right? It's be a different pin. But even with that is the case, if there isn't any kind of protection in place, so let's look and see what's going on. Worst case is we could still brute force this. Even with just 3 attempts before each reset, so there's 10,000 possible 4-digit pins. If we had each 3 guesses, so the total chance we'd have to guess 3 times and get it right, or get one right, get lucky and get one of the 10,000 is probably under 0.5%, I would guess, which sounds like, oh, there's no chance, but we'd only have to do that probably about a couple hundred times to have a 50% chance of success. So if you think about it, that's only sending 600 requests to the server, which is not many at all. So we definitely can just brute force this setup. So if we look at if we look at one of these, it looks like it's same thing, except now they're is sending an attempt number and OTP, which I'm assuming means one-time PIN. Let's go ahead and send this over to repeater. And let's just go ahead and see what happens if we get rid of attempt number. So portal login. So it looks like it just, without that, it looks like it's just a normal login. It's telling us it's sent, and we have 3 attempts to enter it. So let's see what happens if we give it like a 0. It looks like it tried it. Invalid security code. What if we give it one that's too big? Too many wrong attempts. So it looks like what it's doing is the server's not actually keeping track of our login attempts. It's using this parameter in our post request client side to keep track. So when it's incrementing it, and when we get above on attempt number 3, if we still haven't gotten it, then it's telling us to go back to the login page and do it all over again. And if we give it one that's more, it's not even accepting it. So that's good news for us. It also makes me think it's not resetting the PIN number each time. So we should just be able to send a request and brute force through the PIN without even having to worry about doing that whole login every 3 attempts. So I was trying to think what I said. I wanted to do something different every time. For this one, let's go ahead and we'll make a bash script, and we'll try and get in that way. So let's open up, let's just call it. So full disclosure is I don't really know bash all that well, but I know it good enough just to do something like this. And that is something I do want to like emphasize is I think it's a really good thing to try and do the same thing multiple different ways. There's just a lot of like research and data that shows that the way information's mapped in our brain, the context of how you learn it and how you implement it actually helps. The more different ways you can do the same thing, the more it's kind of like solidified in your brain. Helps you understand it deeper, recall it better when you need it. So it really helps to be able, even just something like this, right? I was just going to be brute forcing a login type deal. Like if you can do it in a bunch of different tools, you're going to know it way better. Just the process itself, you'll understand it and remember it and know it better than if you just only know how to do it one way. And also, just as importantly, especially in kind of like this field and area, is you're just much more versatile. Like you don't want to get stuck in the kind of situation where like, oh, you can only do this thing, but if you have this exact specific tool, or you can only program if you have this specific IDE, because you can't remember how to do it other ways or using other things. So like, even though I'm not very good with bash, like I know it just a little bit enough to kind of do something like this. So like, imagine if somehow we got like a SSH shell into a box and we were going to try and pivot to something else, and like you don't have your normal tools, or all you just have is maybe just the command line. So being able to like write a bash script then would be like super, super helpful. So it's definitely worth spending the time just to try and do it different ways. Like, I mean, if you think about it, I'm assuming like the reason you're watching this video, I mean, I know there's a lot of people who do this just because it's fun, but I think for a lot of us, especially me, like I'm doing these just because like I want to learn and get better. And so like the flag isn't really the goal. It's just kind of the excuse in order for me to like be motivated enough and do things to like work at getting better. So even if it takes more time, like I could have already finished this challenge probably if I was just using Burp Suite and like going through as fast as I could. But like if you spend the more time to do other ways, even if you already know how to do it and could finish the machine quicker, like you're better off doing that because it's making you better, which is kind of the whole point of why you're doing this for a lot of people anyway in the first place. So all right, yeah, anyway, off my, I guess it's not even really soapbox, but I'll shut up now and stop rambling. So we're going to just do, what we're going to do here is we're just going to do a for loop, and we're going to iterate over every possible pin code. We're going to send a curl request, and then our script will end. And when we get a successful curl request, we'll output the data. So one thing is, let's go ahead and we'll figure out the correct curl request that we want to use. So when we curl, if we're going to send something like this, we want to tell it what method. So we're using post. You could use put, delete, whatever. You capital X for that. And then, like I said, we have to give it this data. So we're going to give it -d for data. Now I could just do it like this, and then we would change our variable here. And I don't actually know what like the best way is convention-wise, but we can also just go ahead and give it a key value pair for each -d, and it'll go ahead and assemble it correctly when it sends it. So like I said, I don't know what the best way is. It'd work either way. We could have done it the other way too, but I always just go ahead and do it like this. And this is where we'll have our variable when we put it in our script. We do need to give it, there's that old annoying cookie header we have to include every time. Oh, you know what we could do? So we could do header and then do cookie like we have been doing, but with curl you can also do just -b for cookie. So that's how we'll give it to cookie. And then we will give it the address. /staff portal login. That should be right. We should get back a request telling us that it was invalid. Invalid pin. Did I not give it? What attempt did I say it was working on? Attempt equals 1. Why didn't it say, or am I just missing it? Oh, here we go. Invalid was broken up. Invalid security code. Okay, so we know this is a good request, and then what we could do is get the request, look just how we did with Hydra, look for that phrase that we don't, and then the one that doesn't have it is probably our winner. But I want to do something a little different because it'll make it easier programmatically. I'm going to go ahead and assume this is the last step in the login process. And so instead of a 200, what we're going to get back is a 302 that's going to redirect us to wherever it is we go when we log in, and it's going to set a cookie. So instead of doing that, I'm going to tell it that we want to grab the response code. And we do that by doing, hopefully I can remember it. It's HTTP status, I think. If not, we'll have to look in the man page. Oh, and I also think it is, I can't remember how this goes. Let's try that. No, that was not it. So what this W does is it grabs whatever we're giving it here, and this is just how you give it a variable, and this is just straight up from the curl man page. One of the variables you can give it is the HTTP status. All right, so let's look it up because I don't remember. So we're just going to go to curl man page. You can do it from the command line too, but and then it is -W. There we go. Write out. So it stands for write out, and then I'm guessing these are the, I remember having, here we go. Oh, it's just HTTP code. So we do it like that. And then how we want it to write it out. So HTTP code. And if we wanted it to have a new line after that. So, okay, so what this is doing is it's write out whatever's in the parentheses, and we're giving it a variable, so it's going to write out this code. We could put whatever we wanted here, and it would write it out every time. So here we see it wrote out the 200. So we don't want any of this other junk. So what we're going to do, instead of having it output to the terminal like it normally does, we are actually going to write it out to a file, but we are going to write it out to dev null, which is basically like anything you send there is off to the abyss. So we're writing out a file, and it's not actually going to go anywhere. And so now we should just get back the response code. Oh, and let's go ahead and do silent mode so that we don't get any of that stuff. So here, now when we send a request with pin, what we get back is the response code. And so we're going to iterate over all 10,000 possible pin combinations until we find the one that gives us a 302. So we know this is the request we like now. So let's go ahead and copy that, and we'll put that in our script, and we'll save the response as status. And then here's in bash how we do it. So basically this is going to spawn a little sub shell and run this command, and the output from that is going to get put into the status variable. And then so we can, for right now, I'll just echo it. So we should get a whole bunch. And so we're going to have to do a couple things because you're going to see what the big problem is here. Did I type something wrong? That should work. Well, one thing I know I did wrong is I can't, my cursor is right on the, we wanted to give it variable. We want that to change every time. Oh, here's what I did wrong. So this, I don't think this would work. The cookie is not actually, that's in our terminal window saved as the cookie. We need to include, put it in our script. For our script, let's just go ahead and call it my cookie. And then we'll change that to my cookie. And oh, that's why it didn't work. I have to give it a closing. But I did that. So now we should just skip. Okay, so I did do it. I just didn't find it. Line 9. Oh, here it is. Okay, so now we should just get 200, 200, 200. Right, so this will work. We can do this. But as you can see, it's going to take quite a while for us to run through 10,000 of these, and we don't want to do that. So, and again, I'm not the best at Bash. So this, if you are, you might be looking at this going, this is hacky. But what I'm going to do is create, let's do it like this. I'll create a function. We'll call it post pin because we're posting our pin. And we are going to move this stuff into here. And we're going to have to change our variable because now we're not doing I. We're going to use what we pass in. We're going to use the first parameter we pass in. In Bash, you don't stick parameters, give them little names inside the brackets like you do in most programming languages. You can pass in as many parameters into a method as you want, and it just takes them by order. So like what we're going to do here is we're just going to say post pin, and we're going to give it 1. If I gave it, I could give it another 1. Now if in here somewhere I put $2, that would be the variable for banana. If I spelled that right, I actually don't know how to spell banana. So this should do the exact same thing. But the reason I did this is, and maybe you could have done it the other way too, but again, I don't know it well enough to know. What we're going to do is actually, here, let me turn, well, one thing too, is we don't want to send, when the pin is like 8, we don't want to send 8, we want to send 0008. So the way we do that in Bash is we can put leading zeros and it'll always do this. But just to show what's going on, I am going to do, let's just do 50. What I'm going to do, since that's going to be way too slow, is you can't do threaded stuff, I don't think, in Bash, but you can do multiple processes. So what we are going to do is add this and what this is going to do is going to background it. So it's going to go through this for loop 50 times, and it's going to run this function, stick it in the background. You know, it's going to work in the background, and then immediately it's going to go do the next one. And so it's just going to run through this as fast as it can and background all those, and then these will all finish out in the background. So it should be a lot faster now, which you can see here. It went so fast, we got several 429 requests in response, which is what happens when you exceed the rate limit. So we need a way to slow it down, and here's where we're just kind of be hacky about it, is we will slow it down, and now we're going to tell it to sleep for 1/10 of a second. So it's going to fire off this into a background process, sleep for 1/10 of a second, and do it again. So technically that should be 10 requests a second, but you know, overhead and all that stuff. Let's go ahead and do every 20th of a second. So this should be slower than before, but still much faster. And you can see, like, oh, why does these come back after we're done? Well, because those ones were still running in the background when it finished this for loop, but they're still going to finish everything we tell it to do. So what we can do here now is now in this one, we can just check the, I'll have it print one so we can see where we're at. We can have it just check the status code and we'll have it print out. So what we'll do is we'll say if, so you do if statements and bash. So if the variable status is equal to 302, then we are going to echo out to the console. We'll say found. The pin is 1. And then we give it the backwards if to tell it we're done with that. And that should work. Oh, yeah, let me echo just so we see. Here, I'll echo the status. Actually, I don't. I mean, it's just going to do the same thing we did before, which we already know it worked and was decent enough speed. So that would go a lot faster. And that's, going to finish in a reasonable amount of time. But again, for the sake of the video, I'm just going to skip ahead and I'm going to cheat. I'm pretty sure it's in between these two values, if I remember right. So hopefully. Apparently not. Trying to, I can't remember what it was. Oh. No, we're getting 200 responses. Password thunder, attempt 1. There's our one-time pad that we're changing. Oh, that's why. We passed in, we want to pass in I. So I was sending in, I don't even know what. Oh, so hashtag 1 would have been nothing in the scope of this because we passed in no variable into our script, if that makes sense. Did I save it? And also, oh, okay, I was going to say, and also maybe I don't remember the pin, but I do remember it. So we can see here the pin is 3798. So let's go ahead now and we don't need that anymore. Let's log in as Archie. So here we get the second flag. And now we also get we can read his messages and we can go to uploads. So we see there's a message from Archie to Amelia, which is a name we have not seen before. Don't need that anymore. Thanking her for her last day of work. So this would be the missing employee 3, it looks like. And only admins can view this site. Let's see what that request looks like in. So we do see now we do have this token, so that's how it knows who we are. It's letting us go to the page, but what the page displays is only admins can view this. So kind of a tiny dead end in that there's not any more big juicy things that we still haven't quite looked at, but there is one thing we can do. We do have another username and password now, or username. So let's see if she has login access. What was it? Log out, I think. That should just clear whatever that cookie token set was. So let's try and log in as Amelia and see if she has So it does, looks like we're good here. Invalid email password combination. So we do know that she has login access. Has login to pass. So let's just do like we did before. We'll use, we'll just brute force all the passwords. Trying to think what I should do it with. Oh, you know what? So I said I always use burp for everything, but I didn't actually show it. So let's go ahead and I'll do it with burp. So that should be the last one we made. And so now I have the Burp Suite Pro, so that there's not any kind of limited. If you're using the free version, there is actually, when you do intruder, it does slow it down, but it probably would still be okay for something like this where we're only going to send 100 requests. I can't remember how long it takes to slow it down. You might be able to get in a couple hundred, maybe. I don't remember. But so the way the intruder works is whatever we put in these little squigglies is what we're going to be changing up. So we're going to want to change the password every time. So we'll just use the sniper attack. There's a couple different ones. And what we're going to do is we're just going to give it a simple list. We're going to be using the passwords word list. And then let's go ahead and let's put in a delay between each request. I don't remember. I think I could still use 10 threads and it would be okay. I don't remember. And then what we're going to do is just like how we did before, we're going to tell it, we want it to flag everything that says invalid email. And then we're going to look at the one that doesn't have this. So it's just going to mark all these. You'll see in a second. I think that should be good. Yeah, so see everywhere it's flagged, it has invalid email, and then we're going to let it run through all 101, and then the one that doesn't have that should be, yeah, so this request number 69 did with this payload. Looks like we can log in with that. So now we know her creds. And then if we get this, oops, if we get the whole pin thing again, we already know how to brute force our way past that too. So no big deal. So let's go back here and we'll log in as Amelia with that gibberish I can't remember. And unfortunately this time we don't get a pin. We need the answer to her login reminder. We'll just go ahead and see what the process for that is. Looks like we can just keep entering it in. Doesn't say we have X amount of attempts. If we look at our proxy, we see no attempts, just the answer. So kind of unfortunate here because this isn't something we could really brute force. But we do have some information, right? What's the name of her local pub? Well, it's probably near where she lives, right? Well, we do have her name. So this is one of the cool things about this site compared to like a lot of the other sites is this is much more like how you would do it in the real world. Let's just go ahead and search for Amelia Nixon. I guess it would help if I. So, you know, maybe we can check for Instagram, LinkedIn, Facebook. Now, so it's much more like reality, but also we do have one advantage in that this still is just a challenge site. So the guy who made it probably isn't investing any time keeping his, you know, sock puppet accounts for the purpose of this stuff up to date. So we could, you know, kind of exclude stuff where it looks like they have, you know, some posts and some followers. But what we're going to see, unfortunately, is that there are a lot of Amelia Nixons. So this would be too many for us to kind of like go through. We're going to need some more information. Now, one thing to think about is, let me do it in Windows. If we knew what she looked like, maybe that might help us. Then maybe we could match it with a LinkedIn or a Facebook a lot easier. They never got rid of her login. So we know these pictures of the employees are stored on a server. Maybe they didn't get rid of a picture either. And if we look at the way the pictures are formatted, we saw that there were these hashes. Oops. I don't know why I did that. So we got this hash. And so like if we went to because his user employee number is 2, this would get us the exact page where the exact file on the server where the images is stored. Well, so somewhere there's probably a 3 with a hash that would get us Amelia's picture, hopefully. And then we could use that maybe to figure out what she looks like, and then maybe we can get, Google reverse image search. Maybe we can find an account that belongs to her, figure out where she lives, find her local pub, and then get in that way. So one of the things we always want to do is like, and even if like we didn't need this, like if we were going to run into a dead end or whatever, it's still always helpful if you can figure out something has to be put into the hash function to generate the hash. Well, what is it? Is it their name? So we could do something like go to, this is an MD5 hash, which there are tools that you can put in a hash and it'll identify it for you, but I just kind of know it from experience. It looks like an MD5 hash. We're going to go to MD5 hash generator. And so what was this guy's name? Archie. So we could say, oh, maybe they're hashing the username or the email address, but no, those hashes don't match. Maybe it's just his name. No, they don't match it. So you can keep going through that. One of the first things I tried when I did this was I actually thought that maybe this was like actual real software. Like maybe there's some kind of, this is just a software that I could go find on GitHub and then look at the code, and then maybe that's how I'd see what they were hashing to get this. The other option, something you always want to do when you're looking for hashes is, or trying to figure out how something is hashed, stick it into Google. Now, you do kind of run the risk on a challenge, if it's like a challenge that you're going to get spoiled, because maybe it'll bring up stuff related to that challenge. We see there's not even anything here. But the other thing you can do is go to one of the crack sites. So like, they have like, that's a cool 404. They have like 20 gigabyte wordless files that they run everything through. And so if this was created from something that was, a word or somebody's name or all kinds of different things, maybe that will tell us what it is. And which is what we see actually is kind of going on. We see it was made by, if you were to MD5 hash 1118, you get this hash, which makes sense, right? If you think of this as the time, one of the common themes that sites will use if they're going to change, because right, a lot of sites you want to change the file, if the file name, especially if it's like user supplied, so that they can't know what the file name is going to become. There are also exploits if depending on how they handle the names and all kinds of stuff. Basically, you just want to change the file name. So typically they'll just hash it. And one of the methods they'll use to hash a lot of time is the time the file was like uploaded, which I would assume is what this is doing. It's just this file was uploaded at 11:18, so they hashed that and got this. So what we're going to do, hopefully, is her picture's still there and we can find out what it is. So we're using hours and minutes. What is there, like 1,440 minutes in a day? So that's, that's not that many requests. We can send that. We can brute force that. So we're going to hash every single combination of time, and we're going to send it to that URL 3 with the hash, and then the one that gives us a bunch of data back. Actually, we don't even need data. We could just use, because I think if it's a fake page, it doesn't exist, right? Because this is user 3, but it was the wrong hash. We're going to get a 404. Yeah, 404. So we can just analyze the response code, and hopefully we'll find one with her picture. So let's just go ahead and do let's do a Python script. So let's go about doing that. We're going to import requests, and then from hashlib we're going to import MD5, and then we're going to go to this URL. Let me do this. Oh, we need our cookie. My cookie. Let's do it this way. So we're going to run into the kind of the same problem again with we can only, if we use just the normal requests, it's single threaded, so it's going to take a long time to send a whole lot of requests. So what I'm going to do is create. So you could do it multi-threaded, but I'm not very good at that in Python. So I'm actually just going to use the sessions instead of requests. So in requests, each time, probably hope if I spelled it right, each time you send a request, like it opens a different socket in the background and all that stuff. Where if you use a session, it keeps the same one. So it's like way faster. It's still not going to get us up to 10 requests per second, but it should be fast enough. And given that we're only going to send at max 1,440 requests, it'll be plenty fine. So we're going to do, let's say S equals request. I'll use the session. So we're creating a session, and then there's several different ways you can, because we need this cookie, right? Add the cookie to the request. The way I always remember to do it is requests, utils, add dict to cookie. I think it's just one word. And then we give it the session, which is S, it's cookies, and then we're going to give it my cookies. So that's why I made it this way with the instead of cookie equals all that stuff. I think there's also like session.cookies.set, and then you could set the header, whatever. There's a ton of different ways. Anyway, so what we're gonna want to do now is let's just iterate over every possible combination of hours. There's 24 hours in a day, and then all the different minutes. And then just like in the pin one, we want, we don't want, like if we send it 108, right, 1 hour, 8 minutes, we want it to be 0108. Although I guess technically that might not be true. So if we don't find anything, spoiler alert, we're going to find something. If we didn't find anything, I would go back and do it again. And instead of say like if it was like 417, instead of sending 0417, maybe just send 417 and try it that way. Because change a single bit in the data you stick into a hash, and the entire hash is completely different. So, but whatever. So we're going to use F string, and the way to do it here to format it so that you do use 2 digits, even if it is only 1 digit, is like that. And then we get the separator, and then we're going to do the same thing for minutes. And then what we're going to do is we'll get the hash of this. So we'll say the digest of that is the MD5. You always hash bytes, so we're going to take that string we just created and we're going to encode it so it's in bytes, and then we will get the hex digest of it, which will return the string, which we then are going to stick in our URL. So we'll use our main URL, and then we know, this is why I kept saving that. We're going to do it to uploads 3. This is where we're going to put our hex digest. And that should be the URL we're going to send it to. And then what we can do is we'll get the response. So we'll get the response from our URL. And if the response status code is equal to 200, we know there was an image there, so we will print out the URL so we can go look at it, and then we'll just exit the program. So we're actually going to have to import sys as well. Now, just to make sure I did that right, let's just rip off 60 of them to make sure the program runs okay. Oh, I'm not echoing anything out, so I don't even know what it's doing. Let's print out the time. So we can see, it's doing 5 requests a second. So, but we're not doing that many, so this would be okay. If we need to do a lot, I'd either learn how to do threaded better so I could always do it, or I would use a different tool. But we could do this. And then again, since I don't want to have to edit things because I don't know what I'm doing, we're just going to go ahead and I think I remember what the time was. So we're just going to check these just to shorten it. But obviously it'd be the exact same thing. And it looks like it's going to be that. So this looks like it should be our so now we should hopefully have Amelia's picture. Yay, hello Amelia. So now we could save this. And we could do some reverse Google images. We could go through, see if maybe we can find one that matches. One of the things you want to always go ahead and do is we're going to look at the EXIF data of a picture. Maybe there's some header or some information in there that will come in handy. Spoiler alert, there is. And so we're going to use EXIF tool, which again, it's something that just comes with Kali. And let's see, where did I just save that? What was it called? 3. And hello, looks like we get the GPS position of where this picture was taken. So now we don't know where it's taken. Maybe it's by the office. Maybe they took the pictures at the office. Maybe it's at her house. Who knows? She could have been on vacation and she's in, Bali. But it is an avenue for us to check. So we could just go to Google Maps and put that those coordinates. I probably shouldn't show that. Now you know what city I live in. Oh no! Or at least what city my VPN is in. So here we go. It looks like we get these coordinates. It looks like it's in the United Kingdom, which is good, right? Because that's where we know the site is. And we know we're looking for a pub, so we could use the nearby, start looking for stuff like that. But we also see right here is a pub. Oops, no. There we go. So let's try this one. What is the name of your local pub? And we see that indeed is her local pub. So here we get the third flag. She doesn't have any messages, but let's see if we can get an upload. So what it looks like is Amelia. Remember, you had to be an admin to see this. It looks like Amelia is an admin. Download file listing from. So we get this. Let's see what it does. So it looks like it's giving the listing of all the files that are on that server. Let's look at that request in. Okay, so yeah, the uploads. So that request was, looks like it's sending a post request, listing file, and it's giving it a file. So what happens? And it's getting it from there. So that makes me think that what is going on is this is an actual file on that, which we see it is. So what it looks like it's doing is it's something in the, if you send a post to uploads, let's see what happens if we don't, if we give it something else. Let's just say blah. I gotta send it to repeater. Blah equals blah. Nothing. But what if we give it nothing? Oops. Okay, so I didn't actually look at it that close last time. So what it looks like it's doing is whatever is on upload is it is just taking what we give it, and then it is getting the response. It sends off a response and sticks it in this files variable. So like a real one, if we looked, and so when they wrote this, you know, they coded it up and said, okay, we're always going to get this file, so we'll just go ahead and make it so it's going to take this JSON information we give it, and then it'll neatly display it out into this list, and then we can iterate over that list. So when you give it something it doesn't expect, like let's give a file that doesn't exist, it's probably going to say like page not found, and then now it can't iterate over all that. Yeah, so nothing happens. So here again is another instance of where the data that we control, we're giving to it, and it's being put directly into something that is being used as a web request to this specific domain. Now, if we'll remember, this domain here actually had a redirect page, yeah? So we said from the start, one of the first things we said was we're probably going to need some kind of SSFRF, or I said that wrong, but you know what I mean, because we're going to need to get the server to probably go to that admin page. Well, now we've got a way to do it, right? Like if we tell it to go, because it's just going to go, whatever we put here, it's going to go to it's going to insert here, and it's going to make a GET request to that. So what if we tell it to go to redirect, and then we give it the URL. Where did we want to go? It was admin.VulnRecruitment. So if it's set to follow redirects, it'll follow the redirect now to there. And since that request is originating from what's hopefully either on the same server or behind the same, it's on the same subnet mask or whatever, hopefully it's something that can access this, and then it'll hit that and then return that to us. And stick it all in, maybe you need HTTP. And var files equals nothing. Did I spell it right? Is it admin? Well, either my internet dropped or I'm just spelling it wrong. My brain's kind of fried, so it's probably the former or latter. See, I can't even get that right. Copy URL. Okay, so I just screwed something up. Where was I? I was doing it from repeater. Redirect URL equals. I don't know what I did wrong. But now we see whatever page it is that this admin is simply just returns this. So there is our fourth and final flag. There were only 4 of them. So yeah. Hopefully that was interesting. Hopefully you got something out of it. I mean, truth be told, probably no one ever watches this, so it doesn't matter anyway. But if you did, thank you very much for watching it. And I hope you learned something, or it was enjoyable, or you got something out of it. And yeah, thank you. Have a good day.